So let's see. So this is review. It reviews what vertex form is, and it reviews for your quiz a little bit tomorrow. The only thing we're not going to do with this problem is graph it, but as long as you can plot some points, plot X-intercepts and turning point, you'll be okay for the plotting tomorrow. Do you remember with vertex form how to find the turning point or the vertex? How do you do it? -1. Yeah. -1, take the opposite of that middle number, and what would be the y? -24. Good. All right, so that's where your vertex would be if you plot -21, comma, -20, or -1, -24. Now, we have to decide if this is a max or a min. So remember, we look at the 6. The 6 is positive, so does that mean your parabola opens up or down? Up. So our vertex is going to be a minimum. Do you guys remember where the axis of symmetry will be for this parabola? At the x value. So you have to make sure you write this as an equation. So you have to write x equals -1 because the axis of symmetry is a line. So you need an equation. Now, how do I find the y-intercept of our graph? Put 0 in for x. So we'll find the y-intercept, keep the y the same, we put the 0 in for x. So we'll have 6 times 0 plus 1 squared minus 24. And you can simplify that. So we have 1 squared, which is 1. 6 times 1 is 6 minus 24. And 6 minus 24 is -18. So our y-intercept is at 0, -18. We can plot that point if we wanted, so we would have 2 points for our graph. And then if I can find the y-intercept, how do I find the x-intercepts? You make y 0. So we would put 0 in for y here, so we'd have 0 equals 6 times x plus 1 squared minus 24. And you're going to solve that little equation for x. Which part do you have to start with when you're solving it for x? The 24. So we start there by adding 24 to both sides. This should seem familiar after yesterday. And you'll get 24 equals 6 times x plus 1 squared. Then you would deal with the 6. So you would divide both sides by 6 and get 4 equals x plus 1 squared. Now what's the thing you have to remember when you take the square root here? You have to write a plus or minus. So the square root of 4 is plus or minus 2 equals x plus 1. And then when you subtract the 1, you stick it in front of the plus or minus. Okay, so what would be your x-intercepts? -1 plus 2, which is 1. And -1 minus 2? I know you're all screaming it in your head. -3.
Oh my god, that dog that is a cute dog.
Yeah.
There's a cute dog outside.
The windows.
That was a cute dog.
I don't think they're not right. I can't even. They're not right on
They were behind me.
You could open it.
I mean, that was a cute dog.
They like go up and down all day. I don't know. All right, we go with that part, right? That's what's probably going to be on your quiz tomorrow. So there'd be that, and then finding, making the graph. So plotting 3 points, making your parabola. Now this part over here is not on your quiz tomorrow, but we are going to do it today. We're not going to do this a lot, but we're kind of making a process point here. Yes, Bobby?
How did you do?
-1 plus 2. Yeah. You're fine. All right, now we're going to take this. We're going to take that vertex form, this equation, and we're going to put it into standard form. Standard form is the equation of a quadratic with no parentheses. Ax squared plus bx plus c. And there's pluses and minuses to both, but let's at least work through the process here. Does anyone have an idea where you would start to get rid of the parentheses in this problem? No? That's okay, I'll tell you. We're going to get rid of the x plus 1 squared. What does it mean to take the quantity x plus 1 squared? You're going to end up boiling. You have 2 of them multiplied together. So right now we have y equals 6 times x plus 1 times x plus 1 minus 24. That's where you have to start. You can't distribute the 6 or anything. You have to to expand the square. Now, yes, you could distribute the 6 here, but my suggestion is that you start by dealing with what's in the parentheses. Just get rid of those first, and then we can distribute at the end. So we will have 6 times, let's figure out what would be in our parentheses. We'll have x times x, which is x squared, x times 1, so 1x, plus 1x, which is 2x, plus 1. Now it's pretty easy, right? Once we squared, got rid of that parenthesis, we can distribute the 6, and then we'll subtract 24. So we'll have y equals 6x squared plus 12x plus 6 minus 24. And what happens here? What do those add to be? What? Negative 18. That's the same parabola as this vertex form. It's just written a different way. Where did we see the negative 18 already today? The Y-intercept. Anybody have an idea why those are the same numbers? It's not a coincidence. It's actually not. Sometimes it is, but not today. What's the x value for the Y-intercept?
0.
0. All right, so over here we have an x value of 0. If I put 0 in for x over here, what happens to these x values? They go away, right? My mom called that the cover-up method. Those go away. What are you left with? Negative 18. Since they're the same equation, you have the same y-intercept. That's the nice thing about standard form. We'll talk about it a little bit more later, but standard form makes it really easy to find the y-intercept because those x's are going to disappear, and it's always going to be the constant. So that's one nice thing about standard form. Now, I know that wasn't, like, fun, right? I'm multiplying polynomials all day. That's what we're doing in Algebra 1 right now. But it's not fun, but it's not hard, right? So going from vertex to standard form, not difficult. We're going to go backwards now. We're going to go from standard form into vertex form, because actually vertex form is really, really handy, and that's what we're going to spend most of our unit looking at. So we're going to pull out our handy friend, completing the square.
Oh my god. No.
Complete the square, no calculator. And it's going to be slightly different. In general, the process is going to be very, very similar to what we did last semester. However, there are some slight differences. Don't let all these words make you feel like this is going to be any harder than it was before. There's a lot of words. The process is not hard. Okay? So let's start with this problem. We have standard form of a quadratic, x squared plus 6x minus 6. To start with completing the square. Same as last time, except this time we have a y equals instead of 0 equals. We're still going to start to get all the terms with the x on one side and the constant on the other side. Okay? So we're still starting the same way. So what we'll do is we'll start by adding 6 to both sides here. And when we have that, we'll keep the y, so don't ignore the y. We'll write y plus 6 equals x squared plus 6x. Same first step. Now, this is just an aside, which means we'll come back to it later. In order to complete the square, you still have to make sure that the leading coefficient is 1. It means you have to have a plain x squared right here, which we have in this problem. We'll deal with what happens when it's not 1 when we do another problem on the back in a minute. But for now, we're good to go and move forward here. We need to complete the square. We're going to still do that b over 2 squared thing like we did last unit. So I didn't do this yet because I wasn't quite ready for it, but what did we put on either side when we did complete the square last time? A box, a square, right? So let's rewrite this so we actually have a box to fill in. Y plus 6 plus a box is x squared plus 6x plus a box. So we're still going to do that, and from now on, we're going to put that box right up when we move the constant. We can just do plus box on either side. I just wanted to review with you. So again, same as last unit, to actually fill in the boxes, you're going to use half of this middle number. So half of 6 squared. Half of 6 squared is going to be 9. So we'll put a 9 in both boxes. And then we simplify. What do we have on the left now? We'll have y plus 15 equals, who remembers how we simplify the right-hand side? Remember what happens? We had a shortcut. No one wants to tell me though, you just all think it in your head. That's okay. We had parentheses, right? What goes in the parentheses? X plus 3. Right, half of the middle number squared. You can probably see that we're almost done. This is starting to look like vertex form because all you have to do now is subtract 15 from both sides. So you end up with the equivalent vertex form of this parabola being y equals x plus 3, the quantity squared, minus 15. And that's your equation. So if you graph that and the original standard form at the same time, they would give you the same parabola. Before we move on, what is the vertex of this parabola? This half bit. -3, -15. Yeah, so that's your vertex. So make sure you can find the vertex. All right, not too bad so far? Look over.
It's pretty bad.
It's horrible.
It's really.
Are you going to make it through the class? Questionable? All right, we're going to skip to number 2, actually, on back. So number 1, I'm skipping because it's very similar to what we did on the front, leading coefficient of 1. I want to spend the next couple examples working with problems where the leading coefficient is not 1. What did we do last semester when the leading coefficient was something other than 1? Divide. And that worked really great for us. However, we're not going to do that this time. It's going to be a little different. The reason it's going to be a little bit different is because every number, I know, it won't be that much. Every number is, the point of this unit is called transformations of quadratics. So we're going to be figuring out why do graphs move left, right, up, down, why do they flip, why do they get skinnier and fatter and all that kind of stuff. So we need every number in the equation because every number actually plays a part in that. So we don't want to divide out the 2 because when we divide the 2 out, it goes away forever and we still need it there. So we'll talk about what happens to it in a second, but the first step is the same. Move the 16. Okay? So we're still going to do y minus 16. And this time, why don't we go ahead and do plus a box on either side? Okay? We know that we're going to do the plus a box, so we might as well skip to it. Now before we can deal with filling in the square, remember we're not allowed to have a 2 right here. So this time, instead of dividing it out, we're going to factor it out. Okay? And what that's going to look like is you're just going to put 2 and a set of parentheses. You're just going to factor 2 out of both of these numbers. So what would you have inside here when you factor 2 out? X squared plus 4x plus box. This middle term is the one a lot of people forget to factor the leading coefficient out of. Make sure you divide 2, pull it out of both terms. All right, well that's the right-hand side. But the left-hand side is going to be slightly different as well. We're still going to have y minus 16. However, let's think about what happens when we work with equations. You know we have to balance equations, right? So whatever I put in the box on the right, I have to put on the left-hand side. But whatever I put in the box here is not just the number that I put in the box. It's actually 2 times that number, correct? Would you agree with that? So over here, instead of just a box, I have to do plus 2 times the box. So we'll do like a little shortcut recap on the next one, but basically whatever leading coefficient is in front, you're also going to put in front of your box over here. That's going to keep us balanced. Now we complete the square the same way. We take half of the middle number, so 4 over 2 squared. 4 over 2 is 2, 2 squared is 4, and 4 goes in each box. Which you should be able to see that we did add the same thing to both sides, because really we have 2 times 4 here is the constant, which is 8. And 2 times 4 right here we're adding is also 8. So we kept things balanced. Now we'll just simplify. We'll have y minus 16 plus 8. And if you want, you can do that all in one step. What's negative 16 plus 8? Negative 8. Is it okay if I just erase that and write negative 8? So y minus 8 equals 2 times, what's going to go in your parentheses this time? X plus 2 squared. And then all you're left with is adding the 8 to both sides. Tack it on the end. And you have a box right underneath where you can put your final answer. So I'm going to write up here y equals, this is our vertex form, 2 times x plus 2 squared plus 8. So that's vertex form. That's equivalent to the other parabola. What's the turning point? Or where is the turning point? Negative 2, 8. Good. Now you have 2 options here to find the y-intercept. You can either use your vertex form, put 0 in for x, and write it all down like we were doing yesterday. Or we can talk about what we were doing on the front with standard form. Which one is easier to use to find the y-intercept? Probably standard form, because if I put 0 in for x here, I have 0 plus 0 plus equals a y-intercept of 16. So that's there to remind you that your y-intercept is always the constant of standard form. You will get the same thing if you put 0 into vertex form here. It would just take longer. You okay with this so far? All right, let's do one more. Let's do number 3. I'm going to actually make the writing part. It's going to look a lot cleaner and a lot shorter. Okay, so now that we kind of know what's going to happen, we don't have to write as much. So we're going to start by moving the 1 to the left. So we'll have y plus 1. Now we know we're going to have a box, right? But what number on the right am I eventually going to factor out? A negative 1, right? That's our leading coefficient, negative 1. So why don't we jump, if you look at my keys online, this is what I'll do. I'm going to jump right to minus 1 times the box. I'm going to get there anyways. So I like to just skip to that step. It saves a lot of time. Okay, so I added 1. That's where the first one came from. And then this is that leading coefficient I'm going to factor out right here on the right-hand side. So I can't have negative 1. I need a regular 1. So when I carefully factor out a negative 1, what do I still have in my parentheses? X squared minus 6x plus my box. Is that okay to do that? Now it actually saves a lot of time. Just a lot of pencil lead at least. Now we can fill in our boxes. So we take half of the middle number. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9 here. And then we'll simplify. Alright, so we have y. Well, this will give me 1 minus 9. And what's 1 minus 9? Minus 8. So y minus 8 equals negative 1. What goes in my parentheses? X minus 3 squared. This is a lot less work than the last one, right? Now we kind of know what's going to happen. So all you have to do is add the 8 to both sides, and you have vertex form. So your vertex form up here is going to be y equals negative. Now you can put negative 1. I'm just going to put a negative. X minus 3 squared plus 8. What's the vertex of this parabola, the turning point? Positive 3, right? Opposite here. So 3, 8. And where's the y-intercept? Negative 1. Take the constant from standard form. Good. Not too bad. We okay to complete the square. So to complete the square, we will have a quiz on Friday. We'll do a work day tomorrow after your other quiz. The other quiz, again, you have to be able to identify the turning point, the X-intercepts, the Y-intercepts, and this stuff on the bottom. So this stuff we're doing now is going to be on your quiz tomorrow. It's not super hard, but it fits in with what we did yesterday. All right, so this is a reminder of what we've done. When you have standard form, the Y-intercept of your graph is always 0, comma, the constant C. C is for constant, that number on the end in standard form. That's really easy to find. We know in vertex form, it's really easy to find a turning point. In standard form, you have to do a little bit of work. And there's a formula to find the turning point. So first, the axis of symmetry. The way you would find the axis of symmetry is a little equation. We have x equals. The equation to find the axis of symmetry is the opposite of b over 2a. Okay, so that little formula finds the axis of symmetry. Now we do know that the axis of symmetry goes through the vertex, and it's the same as the x value of the vertex. So if you're trying to find the vertex, you also need to use that formula to find the x coordinate. And we'll do 1 or 2 at the bottom. And then we'll see how we find the y coordinate in a minute. So let's use this formula to find the vertex. You do have to, I don't think I gave you that formula, I'll check on your quiz. But you can remember opposite of b over 2a. So in number 1, remember a is the leading coefficient of x. So here a is 1, b is 10, you don't need c. So if I'm trying to find the turning point, I'm going to use this opposite of b over 2a. So what's the opposite of b here? Negative 10. So you'd have negative 10 over 2 times a, which is 1. Negative 10 over 2 is negative 5. So that is the x coordinate of your vertex. Okay, you found that formula. That's the axis of symmetry as well, but that's the x coordinate of the vertex. How would I find the y coordinate of the vertex? I'll get back in for x. So you're going to take this negative 5 and put it in for both x's to find the y value. So make sure you put that in parentheses when you write it down. Negative 5 squared plus 10 times negative 5 minus 27. We're almost done. All right, what's negative 5 squared? 25. You have 25 minus 50. And then minus 27. 25 minus 50 is negative 25. And negative 25 minus 27? Well, you don't have that luxury, so try your best. Negative 52. So that's what the turning point would be. Negative 5, negative 52. So it's a little bit more work, but it's not horrible work. Just makes you think a little bit. That's pretty easy. Let's actually skip to C, because I know for a fact that there's nothing you guys like better than working with fractions, especially when I don't let you use your calculator.
Tell me.
Yeah?
You know it so well.
You knew I had to choose that one other than the other one. I know you so well. I know. All right, let's do this one. Oh, the last one we did today. So we'll start with our formula. X equals. To find the x coordinate, we do the opposite of b. So here that'd be negative 5 over 2 times what's a in this problem? Negative 1/4. Now we're not going to let the fractions freak us out yet because it's not going to be that bad. First, let's simplify 2 times negative 1/4. Negative 0.5, like negative 1/2. Right? So that's what we have in the denominator. Negative 5 divided by negative 1/2. What do you know about dividing fractions? You multiply by the reciprocal. So really what you're doing here is you're taking negative 5 times negative 2 over 1. Or 1 over or 2 over negative 1, either way. That's a lot easier. What does that give you? 10. So that means that the x-coordinate of your turning point is 10. Now it's easy to find the y value. We don't even have fractions anymore. At least this coordinate is an x value, or is in a fraction. And let's find the y. So y equals negative 1/4 times 10 squared plus 5 times 10 minus 20. All right, I have 10 squared, which is 100. So I'll have negative 1/4 times 100 plus 50 minus 1. What's negative 1/4 times 100? Negative 25, and negative 25 plus 50 is 25, and 25 minus 20 is 5. That's your y. So there's your turning point, 10, 5. Now a couple questions. Is this parabola opening up or down? Down. So is opening down, is this a max or a min? A maximum. What's the y-intercept of that graph? Negative 20. 0, negative 20. Good. Okay, so that's what your quiz is on tomorrow. That formula and Vertex Form. Alright, so there's a little bit of practice there for you.